motion graph analysis, and we looked at data from a table and data from the graph itself. And we talked about velocity, speed, distance, displacement, and acceleration. Now, one thing when we talk about acceleration, that means we're talking about a change in the speed, right? And when things usually change in speed is, I gave a small example about objects falling. So when objects fall usually, or what holds up down is what we call gravity, okay? And that's what we're gonna be talking about today. Introduction to free fall. It's introduction to free fall bodies and or objects. So what do we mean when we say free fall objects? What is the thing that's making these objects stay down? So a free falling object, what's the gravity is the main important thing that's holding us all down. And that's the reason why when we drop something, it just goes straight down rather than float up in the air. And that's what's the difference in between the on Earth and over and like up there in the moon. When people go to the moon, the gravity is totally different than here. That's why everything will be floating up there. While as the gravity on Earth, that's what keeps us down, and that's what would help with the free fall. So let's write a small just a little definition about it. A free fall object is an object that is falling under the sole influence of gravity. So an object that is being acted upon only by the force of gravity. So if it's only by the force of gravity, that means there's no other forces acting on that object. Is said to be in a state of free fall. Okay, so there are two very important characteristics of the motion of the free fall. So I'm going to say two important motion characteristics. Motion characteristics that are true of free falling objects. And they are A, free fall objects do not encounter air resistance. Free fall objects do not encounter air resistance. Okay, and the other important one is that all free-falling objects of course we're talking about on Earth, they accelerate. Just think about it. What is the direction of the gravity? It's downwards, so they gotta accelerate downward, and they have a constant value, which is, we call it at a rate of 9.8 meter per second square, or we can say it's approximately 10 meter per second square. So G is always 9.8 meter per second square. If you put it as 10 when you're doing your calculation, that is still right. Now, if you look at this, if you notice that's meter per second square, the unit is meter per second square. And in the previous lesson, we said that the unit for meter per second square is usually the unit for the acceleration, okay? So you should be able to make the connection between this and acceleration, and we'll talk about this in more depth, okay? So we really watch, or we see free fall bodies every single day, all right? And just right. So we talked about how the unit, the SI unit of the gravity is meter per second square. If you look at the previous lesson, it's the same as the unit for A, which is your acceleration, right? And now we know that the acceleration, we know from the previous lesson, is that the acceleration is the change in velocity over the time. And it's given to us in this case that the acceleration, since it's pointing downwards, it would be negative 9.8 meter per second if we're talking about 1 second. All right, so what if I have, let's say this is a person standing here, and that person dropped the ball, okay? And then at time 1 second, well, of course, he started with time equals 0. That means the velocity was 0, which means your acceleration was 0. When the velocity time is 1 second, so once it started dropping, you automatically know that the speed was 9.8. How do you know that? Because we have that, if you look at it here, we know that the acceleration is dv over t. I know that the acceleration is negative 9.8, which is the v over t, right? And then you're going to cross multiply. So, and the t is 1, negative 9.8 times 1 is delta v, which means the speed is 9.8 meter per second. Now there is no negative velocity, that's why here it's positive. Okay? So what if the t was 2 seconds? One time, so let's do this. 1t is 1 second. So now 1t, 2 seconds, what happened here? The acceleration is the same, negative 9.8. I'm looking for the velocity, and the time is 2. So again, we're going to cross multiply. So we're going to get delta V is negative 9.8 times 2. So delta V is 19.6, which is going to go right here. And so on. Let's do when the time was 4 seconds. What happened when the time was 4 seconds? It's the same. You got the acceleration, which in this case is your gravity, is delta V over T. Your acceleration, you know it's negative 9.8, which is delta V over 4. You're going to cross multiply. I forgot the meter per second here. Delta V is negative 9.8 times 4, so which will give you negative 39.2 meters per second. So when time was 4, got the velocity 39.2. All of them are meters per second. Okay, so as you notice that it's actually pointing the object. The object is going downwards at a gravity of 9.8 because we know that the gravity is constant. All right. Okay, so we talked before about the graph, the motion graph analysis. Okay, and we said that when we have, that's time graphs. Okay, so when I have time, so this one here is time in seconds, and I have this one here, velocity, meter per second, okay? And we have the object starting from 0, because as you know, this is like your X and this is like your Y axis. So the graph is going to look like this. And why is it on the negative Y, not the positive one? Because the object is pulled by the gravity downwards, which will give me a negative. So remember we used to do the slope, which is the rise over run. And you got your slope, which is V over T. And in this case, the slope is going to be negative 9.8 meter per second squared. Okay? How do we know that? Because I know that this will give me the acceleration, which is negative 9.8 meter per second squared. Okay? So every time an object starts moving, we know that it is starting from rest. So the question would be how fast. That means what is your X or your D, or how fast is your velocity, and how far would be your distance. That's what we're gonna find out. How do we find how fast, what is your speed, or how far? Okay, so we agreed that the acceleration was velocity over time. So if you're doing it this way, you know that the velocity is a times t. In this case, a is your acceleration. So we can represent a in free fall bodies or objects. In free fall objects is the gravity. Okay, so since this is the gravity, I know that A will be 9.8 equals V over T, but I'm not going to say 9.8. Let me just represent it with the G is V over T because it's a free fall object. Or I can say V is G times T, or I can say T is V over G. Okay, where we know that G is equivalent to 9.8 meter per second squared. Okay? All right, so that will be it for now. We're gonna work on more examples and more equations, but for now I'm just gonna stop recording, and then the following recording is gonna be about more formulas that we're gonna use for the free fall object.